12th Max, Chapter 5, Exercise 5.2, Question number 6, Cos x cube sin squared x power 5. So let me take the given functions as f is equal to cos x cube sin squared x power 5. So product of two trigonometric functions. Now you see that the angles are different. Here x power 3 given, here x power 5 given. So let me make the substitution here. We are supposed to find what is df by dx. Let me take this x power 5 as u, x cube as v. So when I make the substitution here, the f becomes here cos v sin squared u. Now again you have to make one substitution here. Take cos v as p, sin u as q. So again this f becomes product of two functions, p into q. This is sin u is q, so q squared. Now we have to apply the uv product of function method. So df by dx is equal to, keep p as constant, q squared, that is 2q into dq by dx, plus keep q squared constant, so dp by dx. So see here, this is 2pq. What about dq by dx? See, q is a function of u. So I can differentiate q with respect to u only. I can differentiate p with respect to v only. But v I can differentiate with respect to x, because v is a function of x. 3x squared. So u is a function of x. So I can find du by dx is 5x power 4. What is dq by du? Cos u, just cos u. And this is minus sin v. Sin v. So this dq by dx, first let me differentiate q with respect to u, dq by du. And then u with respect to x, du by dx. Same thing, q squared. I want dp by dx, but I can differentiate p with respect to v. So dp by dv, but v with respect to x, dv by dx. Now make the substitution here, that's all. 2 into, what is p here? P is cos v. Q is sin u. What is dq by du? Cos u. Du by dx is 5x power 4. 5x power 4 plus, what is q? Q is here sin u. So sin squared u. Sin squared. dp by dv minus sin v. Just we make the substitution, that's all. Sin v. Then dv by dx is 3x squared. 3x squared. Still we need all the terms in terms of x only. So what is v? V is equal to x cube. What is u? Sin x power 5. Then cos x power 5 into 5x power 4 plus, so you can remove this minus here, because here we have minus. Sin squared, what is u? X power 5. Sin v, x cube into 3x squared. So write the constants in front. So 10, 5 2s are 10, x power 4 cos x cube sin x power 5 cos x power 5 minus 3x squared sin squared x power 5 sin x cube. This is the final answer. See, very easy for you. Just you make the substitution of the function x power 5 u x cube v. So this is function of x, differentiate with respect to x and make this steps, and finally we find the df by dx. So this is your df by dx. That's all. Let me pass on to the seventh sum. 2 root of cot x squared. See the seventh sum, 2 into cot of x squared. Let me take this function as f. I am going to find df by dx. So again we are going to apply the chain rule. Take x squared as u. X squared as u. So therefore the function becomes f is equal to 2 root cot u. Root cot u. So what you do? Make cot u as some substitution. Take p. So therefore we replace f as 2 root p. So you have to find df by dx. Let me write here. We have to find df by dx. So it is function of p. So 2p power half. Root means p power half. Bring half to the side. P power half minus 1. That is minus half. Into dp by dx. dp by dx. 2 gets cancelled. So minus half means 1 by root of p dp by dx. So what is p here? P is a function of u, but u is function of x. So here I can find du by dx is 2x. And what is dp by du? dp by du is cot of x. Cot u is minus cosecant squared u. See, you have to thorough with the formula. Derivative of cot function is cosecant squared u. So I apply here. So 1 by root p. So first I differentiate p with respect to u. That u with respect to x. So 1 by root of, what is p? P we have taken as cot u. Cot u. dp by du we just got minus cosecant squared u. Minus cosecant squared u. And what is du by dx? du by dx is 2x. Now replace here u. 1 by root of cot. What is u here? X squared. Cot x squared into minus cosecant squared x squared into 2x. So this is your df by dx. So if you want further simplification, you can do the simplification here. See what I do. See, this is the final answer, but further simplification we are going to do some more steps here. See, just you listen the steps here. See, I write here minus first, then 2x here. Denominator cot x squared. I write this as cos by sin, no? Cos x squared by sin x squared. See, what about this cosecant? 1 by sin. So 1 by sine squared x squared. Sine squared x squared. So minus 2x divided by, see this, let me take this as to the numerator root of sine x square. Fraction, it gets reciprocal, so it goes to the numerator. So this term you will get cos, you will get in the denominator. And see here, this is root of sine x squared, this is sine squared x squared. Let me split the term sine x squared for simplification, that's all. Sine x squared into sine x squared. So this is equal to minus 2x divided by cos x squared into sine x squared. This is root sine x, I can write as root x into root x. So sine x squared, I write root of sine x squared, root of sine x squared. Why? Because already you have one sine x squared term in the numerator. See, now I cancel this term. So minus 2x divided by, without root you have the sine x squared, but root function here, let me write single root, I bring down in the same root sign, cos x squared sine x squared. Still you can simplify. See, just we are doing the simplification. Still you can make the simplification. See, in trigonometry you have learned one identity. Sine 2a is equal to 2 sine a cos a. 2 sine a cos a. So I have sine a cos a here. Cos x square sine x square. I need 1 2. So what I do, I multiply with 1 2 and divide by 1 2. Everything under same square root sign. No need to write one more step. Just you have the idea. So minus 2. This root 2 cos a sine a. 2 cos a sine a or sine a cos a. These two terms become sine 2a. So I write sine 2x squared, sine 2a. What about denominator root 2? It goes to the numerator, minus 2 root 2x. And this is in the one extra term, sine x squared outside. So this is the final answer for you, book back answer. So this is the final answer. So with that we have differentiated all this simplification. We have to do in the simplified form. That's all. See the 8th sum, cos root x. Let me take that as f. I am going to find what is df by dx. Take root x as u. So therefore the f function becomes cos u. So I take cos u as p, some p function. So f becomes p. So differentiate f with respect to x. That means differentiate p with respect to x. But p is a function of u. So what I do? I differentiate p with respect to u only. So dp by du is equal to minus sine u, but du by dx, u is a function of x, du by dx is, this is x power half. X power half means we bring half to the in front of x. X power half minus 1 is minus half. Just substitute here dp by du, du by dx. So dp by du is minus sine u and du by dx is half of, you can write this is half of 1 by root x. 1 by root x, this is your du by dx. So 1 by 2 root x. And replace u minus sine u is root x. Then by 1 by 2 root x. 1 by 2 root x. This is the answer, final answer. That's all. Very easy sum here for you. Just because I've given you the chain rule, we are applying this. For this simple sum, actually the function is very easy, single sum. Just let me give you the other method also, Oliter method. Oliter method. F is equal to given cos root x. Directly you can do df by dx is equal to cos function, first you differentiate, minus sine root x. Then root x you have to differentiate. First you differentiate the function and then differentiate root x. Root x is half of x power minus half. That's all. Minus sine root x 1 by 2, minus half negative, so root x. So minus 1 by 2 root x sine root x. That's all. So for this exercise you have to apply the chain rule. I have done this. Just make the substitution directly. You can do the sum. Thank you.